Hello everyone, we are team number 1. My name is Srihari Mohan and our topic is restoring degraded artwork through interactive deep learning colorization. Most of the historic images that are available now are either in black and white or in a degraded form. So we are using so many deep learning methods here because doing these whole things manually can be time consuming, expensive and also requires some amount of skills and lot of historic researches. So we are using deep learning models like Degraded and ImageNet, and we have already done about hundreds of papers about this colorization center.
So, as my friend said, we go through 100 papers and we found some common methodologies they use, and they have common issues also. Like, for example, if I say there was some paper like published in 2008, 16 to 18 ratio, like from Sang and Mr. Andy J and all. These guys use GAN training approaches, which is obviously good but not that much accurate. What happened in that GAN was there are these two parts, generator and discriminator. Generator will create fake images where a discriminator need to predict whether it is real or not. So we are using now No.1. No.1 basically focuses on the generative part, and it will clear the first part there itself and then only go to discriminator. So that's the change we are trying to do from some of the common issues from this GAN. The next one we mentioned was every paper are using everything, novelty and all that, colorization there. But the degraded part, they are not retrieving that properly and accurately. That some of them they retrieve it, but no realism is there. So their plan is to mix the Degraded and image to build a hybrid model to make it more photorealistic as well as engaging. Because we all know that colors give life to pictures. So we are trying to give real life to the artwork which was never given a colors. Also we are taking advantage of the historical references, basically the text and about the paragraph and about the explanation about that in there. And why we use Degraded is like we need a unit type model. Basically, we need an encoded decoded type of model which is not and type of level to reduce flickering and all. So, some of the issues are like the GAN training, and some were like the colorization of these things. Some problem occurred was okay, it is colorized, but what if the color is a fake color or false color? So, what we thought was that is a crucial point and crucial problem. So, we were thinking like what we can do. Then we got an idea of blending that with the historical reference, like historical documentations, where we can capture the saturation, contrast, warmth, cool colors, like it is like the elements, focusing on everything, sharpening, lightings, and all. We can focus appropriately. So, doing this, as my friend said, doing this manually takes a lot of time. So that's why we are taking this hybrid model of images as well as Degraded. For ImageNet to take the labeled images to give the accurate color predictions for the particular and respective parts.
Just like my friend now said, the biggest problem with automatic colorization is ambiguity or multimodality. A grey car, for example, a grey car, say an old photo of a grey car that could realistically be in red, blue, or yellow color. But using a classification model, Vibrant still tends to pick the single most likely answer. So to achieve the truly diverse and ultra-realistic results, researchers turned into more using a GAN setup as a generator. And the other main challenge is the temporal flickering. If an image model colors a person's jacket slightly different in frame 1 than in frame 2, the rapid change in color appears to be unpleasant and flickering. The solution is to prioritize consistency. Classic techniques involves optical flow, which mathematically tracks how pixels move from one frame to the next and to another. This flow information is then used to warp the color information from the frame.
Okay, so I'm continuing what he left there. So the next thing, diffusion models. That's what we are now going to focus on. It is the result leverages of diffusion model. Like same technology responsible for this incredible and this enormous quality of this modern text to image generation. So as we all know, there are n number of AI generations and AI things like we can do for colorization. But we cannot predict like as I said before, the false color came as a crucial problem in that technology. So that's why we are hybriding the two key models we are planning to do is DOLFA as well as image stitching. So to discuss, we created a little flowchart. From the 100 references, we mixed up like quite 10-20 papers for the summarizing because there is not much very time. So in the flowchart, we focused on 3 parts like phase 1, 2 and 3. So my friend will explain about the phase 1 and 2 and I will explain about the phase 3. So
So, in phase 1, we use exemplar, which means we have a reference picture, and using the reference picture only, we are colorizing the new image. And we use DOLFA and ImageNet and then compare it. And then in phase 2, we analyze features, objects, artifacts from the image, and then we compare it from DOLFA to ImageNet. And that comes to phase 3.
Yeah, and in phase 3, the model selection. Basically, we will think if it is possible to get a hybrid model that much good, or can we improve the DOLFA model with our own what should we say custom purpose. So, according to our current stats and current work, I think hybrid model is more accurate and photorealistic as in case of the output of the colorization. After this implementation, we still have work. Like we need to give the feedbacks as well as we will update the model according to our customer feedbacks. This is a huge help for artists who are suffering from colorizing the historical works. They can colorize through this model and they can use to make their own artistic creativity on that pictures and all. Also, these pictures can be encrypted to the textbooks for the particular lessons and particular chapters to explain about the such great personalities, such as, for example, like we can say the Dorothy Lang's Michael Mother, which was an incredible photography which was captured in 1936, but which was not able to colorize due to some reasons. And same as this, we have Golden Gilfish picture captured in 1937. So, colorization is a core part in this advanced environment. As we all know, from the beginning I said about the GAN issue, we can solve that, but still an issue appears. So, colorization, colors are a vast sea. So, the prediction of particular areas, particular shadings and all is really difficult. So, we are planning to improve that in our one by one phases. Currently, as me and my friends said, only 3 phases are there, but we will brick by brick phase like increase the phases according to the work on it. Sorry, though.
Just like my friend said, the challenges and future directions. First one is historical accuracy. It ensures the precise historical color accuracy becomes difficult without robust contemporary references. And then the addressing bias, which means the working to address potential biases from training data that could lead to anachronistic or misrepresentative colors. It can also cause wrong colors to represent. And then the multi-modal integration. Future models will integrate multi-modal data, change text, metadata for smarter and more efficient colorization. And our conclusion is the future of historical image restoration can be very revolutionary on how we see this and making history more vivid and accessible. The often image based colorization democratizes access to powerful restoration tools, empowering a wider audience. And together, technology and human insights can provide history in a vivid color. Let's embrace the fusion of AI and heritage to preserve our collective memory and value on this.
So,
Thank you.
for the common conclusion, I will say our literature will be in this. And thank you all very much.